So in this video, we're going to practice the skill of finding parameters that allow piecewise functions to be continuous on any interval. So here for the function f of x, we have a piecewise function where we're at -1/2 x plus 3 when we're less than or equal to 5, and 2/3 x plus k where x is bigger than 5. Notice right away that here f of x means x is our independent variable and that k here is a parameter because it's simply not x. So in order for this function to be continuous, two conditions have to be met. Number one, f of 5 must exist. And since here I can check this condition where x is less than or equal to 5, I can simply plug in 5 to this first part to get -1/2 times 5 plus 3. To simplify this to being -5/2 changes to 3 to common denominator to get 6/2. And this equals 1/2. So really, this checks out because f of 5 equals 1/2. The second condition for this function to be continuous is that the limit as x goes to 5 of f of x must equal f of 5. And since I already know what f of 5 equals from my first condition of 1/2, I can simply evaluate the limit or figure out what the k value is for the limit to equal 1/2. So here, for the limit to be 5, I notice that the limit going to 5 on both sides, from the negative and the positive side, must equal. So here, from the negative side, we knew from the first equation this was 1/2. I simply just plug in 5 into the second equation. 2/3 times 5 plus k. And solve for k. 1/2 equals 10/3 plus k. And then I'll have 1/2 subtract 10/3 equals k. And simply just fraction addition here changes this 3/6 minus 20/6. And it's going to equal -17/6. And that is the k value that will make this function continuous. Here in example 2, we have the g of x being a piecewise function with 3 different parts, with 3 different intervals. And we notice that we have 2 parameters to solve for, this time a and b. So in order for me to do this, I have to know that at g of -1 and g of 1, they have to exist. They have to be defined. And I also know that I have to have the limits being equal. So what I'm going to do first is work off the fact that the limit of as x goes to -1 from the left of the function, it has to be equal to the limit as it goes from the right of the function. And so now here I'm going to be focusing on these 2. So I'm going to plug in -1 into my 2x minus 1. And that's going to equal plugging in the -1 to the ax squared plus bx. And I'm going to be getting -2 minus 1 to be -3. And this is going to equal -1 squared to be 1. So we have a, then minus b. So we have an equation here with 2 unknowns. So we can't really solve for a and b here with this idea alone. However, we are going to tentatively box this in to keep it around. And now we are going to focus on the second part, where now the limit as x goes to 1 from the left side of the function is going to equal the limit as x goes to 1 on the right side of the function. And to make that happen, we're just going to plug in 1 into the bottom 2 equations. And notice this one doesn't have a variable, so we just think it goes to 5. And we have a plus b equaling 5. So we have this next equation. So really now we have a minus b equals -3 and a plus b equals 5. So what I'm going to do is treat this as a systems of linear equations problem. So a couple things I notice I can do here, because this is a plus b and this is a minus b equals a number, they're in standard form. So I'm just going to put them on top of each other and do systems of elimination by adding the equations together, which we have 2a equaling 2, and then forcing a to be equal to 1. Once I have this, I can say a equals 1 back into either one of these equations. This would be 1 plus 4 to be 5, and then 1 minus 4 to be -3. So really here to show it, done. And these two values will make my equation continuous on any interval. Now that you've seen two examples done out, I would like you to take a moment to check out this function where you have h of x equals 1/4 x plus b when it's less than 4, radical x plus k when you're between 4 and 9, and negative x plus 1 when you're greater than 9 or equal to 9. I want you to take a moment and try and see if you can answer this question about what is b and what is k equal to. Now that you have seen the solution, let's walk through Now that you've seen the solution, let us walk through the explanation as I am going to present it. So here, short and sweet, we're going to say, hey, the limit as x goes to 4 for both of these equations has to equal. So I would say at the x equals 4 mark, 1/4 of 4 plus b equals radical 4 plus k, simplifying it to be 1 plus b equals 2 plus k, which really just makes this now b equals 1 plus k. So now I'm going to use the second interval, or second really two equations between at 9 to show that this is going to be equal. So here, we're going to plug in 9 to both equations. So radical 9 plus k equals -9 plus 1. And then making this 3 plus k equals -8. And then forcing k to be -11 by subtracting the 3. And then I can use this k to come out to be back into my other equation, and then forcing b to be -10. There it is.